Good morning to all. Today we are going to see about analog filter design. So here we are having a Butterworth filter. These are the design steps. So step 1, for a given specification, find the order of the filter n. So here we are having case 1. In this, if alpha p, alpha s, ohm p, ohm s values are directly given, you have to use this formula. N is greater than or equal to log of square root of 10 to the power 0.1 alpha s minus 1 divided by 10 to the power 0.1 into alpha p minus 1 whole divided by log of ohm s divided by ohm p. Here we are having another case. If alpha p, alpha s, ohm p, ohm s values are indirectly given, by using this formula only you have to calculate. N is greater than or equal to log of lambda divided by epsilon whole divided by log of ohm s divided by ohm p, where alpha p is equal to 1 divided by square root of 1 minus epsilon square. Lambda alpha s is equal to 1 divided by square root of 1 minus 1 plus lambda square. Step 2, round off it to be next higher integer. For example, n is equal to 1.56, then n equal to 2. You have to consider n equal to 2.26, you have to consider n equal to 3. Step 3, for finding the transfer function for the given value of n. So here n represents the number of values, denominator based upon those n values you have to use this denominator. For n equal to 1 means s plus 1. For order n equal to 2 means s square plus square root of 2s plus 1. Likewise, you have to use this order n equal to 8. Step 4, calculate the value of cutoff frequency ohm c. In here you are having two cases. If alpha p, alpha s, ohm p, ohm s values are directly given, ohm c is equal to ohm p divided by 10 to the power 0.1 into alpha p minus 1 whole power 1 by 2n. Case 2, if alpha p, ohm s, alpha s, ohm p, all the values are indirectly given, here ohm c is equal to ohm p divided by epsilon to the power 1 by n. Step 5, find the transfer function HA of s for the above values of ohm c by substituting s is equal to s divided by ohm c in h of s. So for example, here you are having one problem. Design an analog Butterworth filter that has 2 dB passband attenuation at a frequency of 20 radians per second and at least 10 dB stop band attenuation at 30 radians per second. Alpha p is equal to 2 dB, alpha s is equal to 10 dB, ohm p is equal to 20 radians per second, ohm s is equal to 30 radians per second. Values are given directly, so it is direct method. So n is equal to log of square root of 10 to the power 0.1 alpha s minus 1 divided by 10 to the power 0.1 alpha p minus 1 whole divided by log of ohm s divided by ohm p. You have to substitute this value. Alpha s is equal to 10, alpha p is equal to 2, then ohm s is equal to 30, ohm p is equal to 20. So you have to calculate the value and solve this. You have to get the value as n is equal to 3.37. So n is equal to 4. You have to round off. For n equal to 4, the transfer function h of s is given as 1 divided by s square plus 0.765s plus 1 into s square plus 1.847s plus 1. So the cutoff frequency ohm c is equal to ohm p divided by 10 to the power 0.1 into alpha p minus 1 whole to the power 1 by 2n. So you have to substitute alpha p, n and also ohm p. Then you have to get the value as ohm c is equal to 21.409. So you have to substitute s is equal to s divided by this value ohm c. Ohm c is equal to 21.409 in hs. You have to got this value, then you have to solve. Then for s you have to substitute s divided by 21.409. So you have to solve this, then you got this value. H of s is equal to 0.2104 into 10 to the power 6 divided by s square plus 16.05s plus 458.7 into s square plus 39.44s plus 458.7. The next problem, for a given specification, design an analog Butterworth filter. here the given value 0.9 is less than or equal to h of j omega is less than or equal to 1 for 0 to 0.2 pi. Then h of j ohm is less than or equal to 0.2 for 0.4 pi is less than or equal to pi. Ohm alpha p is equal to 0.9, alpha s is equal to 0.2, ohm p is equal to 0.2 pi, ohm s is equal to 0.4. So here this is the indirect value, so you have to use indirect formula. N is equal to log of ohm c divided by lambda, log of ohm s divided by ohm p. Alpha p you already know, 1 divided by square root of 1 minus epsilon square, alpha s is equal to 1 divided by square root of 1 plus lambda square. Substitute this 0.9 here, then you have to calculate the value of epsilon. Epsilon square is equal to 0.2321, then epsilon is equal to 0.481. Likewise, you have to calculate the value of this lambda. N is equal to log of lambda divided by epsilon whole divided by log of ohm s divided by ohm p. So you have to calculate the lambda value by substituting these ohm s and ohm p and also lambda epsilon. Instead of lambda you have to substitute this one, so you have to calculate the value of lambda is equal to 4.898. So here you have to substitute this lambda and epsilon value here, then you have to got the value of n is equal to 3.34. so you have to round off the value of n is equal to 4. Then omega c is equal to omega p divided by epsilon the whole power 1 by n is equal to 4, you already know. Epsilon is equal to 0.481. Then you already calculate the value of ohm p 0.2 pi. You have to substitute all these value in this omega c formula, then you have to get the value of 0.24 pi. So here for n equal to 4, the transfer function h of s is equal to 1 divided by s square plus 0.765s plus 1 into s square plus 1.847s plus 1. By substituting the value of s divided by 0.24 pi, you have to got the answer as h of s is equal to 0.326 divided by s square plus 0.579s plus 0.57 into s square plus 1.4s plus 0.57.